again, we're starting every day with a little bit of finals review. We're going to be kind of a little bit heavier on chapters, units 1 and 2, chapters 1 and 2, than chapters 3, 4, and 5, because we kind of just finished those. But chapters 1, we did the distance formula yesterday. Today, I want to make sure we look at the midpoint formula. So I threw a problem kind of up top on the margin with the formula. Remember, the formula for the midpoint is going to be on the actual test. So that is not something, this right here, this is not something that you want to put on your note card. Okay? It's going to be there for you. So if the problem on the test says find the midpoint, there are two ways you can do it. The first way is when you look at your x values, can you look at these and tell me what number is in the middle of 3 and negative 2? That's a pretty hard one, so probably not. But look here, can you tell me what number is in between 7 and 5? It's 6, right? So if you can look and see, that might help to just cross out some multiple choice options. So you know 6 is going to be the y value. Now your second option is to go ahead and throw it into the formula. So if I put this into the formula, it would be 3 plus negative 2 over 2, and then comma, 7 plus 5 over 2. Okay, so 3 plus negative 2 is actually 1. 1 over 2 is your x coordinate, so half, and then that's 12 over 2, which is 6. So that's just your basic straightforward, given 2 points, find the midpoint. Okay, that's not the one I'm concerned about. I'm more concerned with this problem here that I actually put in the box. This might be a problem that you want to put on your note card, the whole problem and how to do it. Okay, because you can do that. You can put anything you want on your note card. So you can put an example problem and then how to do it right on your note card if you need it. Okay, so we said on the back of the review is where you might want to be keeping notes for things that you want on your note card. So on your review, the back of it is blank. So if you end up saying to yourself, I don't know how to do that, that's maybe something you can write on the back there. So here's what you're doing. On the back of that review, you're just kind of scribbling notes to yourself so that when you go to make your note card, you can make it, you know, as small or as big as you need because you know what all the information you need to put on it is. Okay? Okay, so when we do this problem, the reason that this problem is different is it gives you A, B, and it gives you the midpoint M. So if I had a picture of this, here's A, here's B, here's your midpoint M. Okay, and you may or may not remember how to do this or remember doing this in the first place, but again, here's a second look at it. So the midpoint is 9, 7, and A is 3, 9. Okay, there is a way to do this algebraically, okay, but because we're in geometry, we kind of talked about the geometric way to do this, and it's actually easier, I think, than doing it the algebraic way. So what we said was, I asked you, how far is it from 3 to 9? It's up 6, so plus 6. So what we said is that plus 6 only got you halfway. It only got you to the middle, to the midpoint. So what we want to do is we want to take that 9 and add another 6 to find your way to the other end point. Okay, so if I take 9 and add 6, my coordinate for B, okay, this is what we're looking for. What are the coordinates for B? My first coordinate would be 15. Okay, and right there you can look through your multiple choice answers and cross out the ones that don't have a 15. Okay, now we do the second one. How far is it from 9 to 7? -2. So we're going to go down 2. So you have to then start at 7. That only got you halfway, so you got to do that again. So start at 7 and go down 2. 7 minus 2 is 5. Okay. Going down to the second one, it says line T bisects CD. I'm going to draw you a picture for this. Here's C, D, here's M. Line T. It doesn't have to be a perpendicular line. It just says any line. It says CM is 3x and MD is 27. Okay, and what we're going to do is we're going to find x. Can you tell what it is already? Yeah? So because it says bisects, that's the word we want to make sure we know. Bisects should say to you, cuts into two equal parts. So the two parts here, 3x and 27, are equal to each other. So x has to be 9. Okay. So we're going on to, so that's our little finals review for today. We're going to talk about polygons and angle bisectors tomorrow, especially naming a polygon, just to be clear on that, because that is. And then we're also going to talk about converse, inverse, contrapositive, and biconditional tomorrow as well. So we got a long list of things to cover tomorrow. But tomorrow is a practice quiz day, so we have a little bit extra time. So we'll cover a few more things tomorrow. All right, I'm going over to the next box here to the side. So yesterday we learned angle-angle similarity. So there are two other ways that you can prove that triangles are similar. So the first one is side, 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 and then the second one is side, angle, side. For side, 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 all three pairs must be in proportion. All three pairs of sides must be in the same proportion. So basically you have to show that the ratio of the sides is 2 to 1, 2 to 1, 2 to 1. You have to show that they're all the same setup. Okay, and if that's true, then you can say the triangles are similar by side, side, side. Okay, for side, angle, side, this part you already are familiar with. Where does that angle have to be located, right? In between the two sides. So we're already familiar with that. So you have to have one congruent angle between, and it has to be in between, otherwise it doesn't count, between two pairs of proportionate or proportional sides. Let me slide that over. So it's got to be one angle between two pairs of proportional sides. So that's what we're going to look at today. We're going to look at the fact, like, we've got five triangles here, and the question is, are those five sets of triangles, are any of those similar to each other? Okay. So we're going to have to squeeze this all onto one. So these are kind of two separate questions here. So we're trying to see, the first question is either triangle RST, which is this one, so triangle 1, or XYZ, triangle 2, are either one of those two triangles similar to the first triangle ABC? So the side lengths are all marked. Are any angles marked there? No. So you're not going for angle, angle, and you're not going for side, angle, side. There's no angles either marked or that you can even get. So you're not looking for side, angle, side, and you're not looking for angle, angle. So you have to show that the sides are in proportion. Okay? So how we do that, we kind of set this up yesterday, kind of like, or 2 days ago, sorry, on Friday. So I did smallest to biggest or biggest to smallest. So I put all of the sides for A, B, and C. I just put them across the top. Okay. So this is my sides for triangle ABC. So ABC is on the top. And then let's check for RST. Now, hopefully you can see that that's not similar just by kind of looking at it, okay? But we're going to check this out. So the smallest one is 3 there. So I'm going to go 3. We're looking good so far. There's a 4. We're looking good so far. But then there's another 4. Are those proportions the same? No. Okay, so these two triangles are not similar to each other. Okay, so how you would say that is you would say not similar, and then you could go 4 over 4 is not equal to 5 over 4. Okay, so showing that those sides are not in proportion shows that they are not similar. That's the explanation or the justification. Okay, so let's try it again with this one. Obviously, this one's going to be a yes because the other one was a no. So we'll go 3, 4, 5 again. And it doesn't really matter that order that you write down for the first triangle. I just went smallest to biggest. What if you went biggest to smallest? That's fine. Okay? But whatever order you do for the first triangle, the second triangle's got to follow it. So I started with the smallest, so I got to start with the smallest number on this triangle. So the smallest number on this triangle is 6. So we'll go 6 and 8 and 10. Are all of those in the same proportion? Yes, they are in a 1-to-2 ratio. So you have shown this is yes by side, side, side similarity. Okay, so yesterday was all about angle, angle. There was no other options. It was either angle, angle, or no. Now we have 3 options on the table. We have angle, angle, side, 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 and side, angle, side. So I want to show you an example that has some angles involved. So that's a side, side, side example. It's pretty straightforward because you can see that there's no angle markings at all in the picture. Okay, so it has to be side, 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 or nothing. Okay, so then down here I want to show you some examples that might have angles involved. Okay. Okay. So the first thing we want to do is we want to come right in here and we can mark these vertical angles. We talked about that yesterday. You can mark vertical angles. You can mark reflexive angles. You can mark alternate interior angles if you have parallel. All of those things can be marked, and that's on the other side of this note. Okay, so I marked that vertical. Now I have to show that the sides are in proportion. Let's just say for a second that you're not paying attention. Okay, and you just write the numbers all willy-nilly. Okay, so the first numbers I have for a triangle are 8 and 7. So I go 8 and 7. Okay, and you're not paying attention, and you say, oh, 8's up here at the top, so 8 must go with 3.5 that's here on the top. Okay, and you go 3.5 over 4. Are those two ratios the same? No, they're not. So you would say, no, these triangles aren't similar. But if you stick to the smallest to largest idea or largest to smallest idea, this wouldn't happen. Okay, so right here, you picked the biggest number to go on the top first, that's 8, but you didn't pick the biggest number to go on top on the bottom. So just be careful when you're putting the numbers in and you're checking the ratios, you're checking the proportions. You want to make sure to stick to either smallest to largest or largest to smallest, okay? So if I go 8 here on the top and then 7, I would want to go 4 and then 3.5. And that does show that those two are equal. Okay. Okay, let's look at this last one. Do you see the two triangles? They're kind of hard to see, but we've got this one right here, this PQT. And if you're just looking, it actually looks like these two triangles are not similar. But we have to be a little bit careful, okay? So let's start with the smaller triangle. On the small triangle, what are your 3 sides? So we've got a 4, that's the smallest, a 5, and a 6. Okay, you've got to be super careful right here that you are not ever going to use this number 8. That number 8 is not actually a side of a triangle, right? If you're looking at 8, then you're looking at this little quadrilateral over here, but that's not a triangle. So we don't want to use the number 8, and we actually don't want to use the number 2. So when you do the other sides are going to be 4 plus 8, which is 12. That side's a 12. That side's a 10. And that side is an 8. Okay, it's super tempting to want to use this little number 8 over here, but that 8, again, this little 8 right here is not actually a side of a triangle, so we don't want to use that one. We want to use 8 and 10 and 12. So then if I put them in order of my 8 and my 10 and my 12, are those similar to each other? Yes. And they are similar to each other. All of the sides, this is by side, side, side. You could actually also use side angle side because both of them have angle P involved, but it's a little bit more difficult to find out the two side lengths. So what happened was the triangles are actually flipped. They are both using angle P, but their directions are flipped, which is why they look a little bit different from each other. Okay, but if you stick to the smallest to largest, you should be okay. All right, so that's the bulk of the lesson today, is making sure you can decipher between angle, angle, side, 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 and side, angle, side. Okay, but we're going to just do a little bit of algebra now. So flip this over here, or go back down to the bottom. Okay, we're actually going to work out the problems from this triangle, but we'll just set up the problems for the second triangle. Okay, so it says, find the values that would make the triangles similar. Okay, well, the triangles are similar by angle, angle. They have the angles marked, so we can go ahead and set a few things up. So let's start with, let's say I want to solve for this 5y. Okay, so I always look for what I'm trying to find. So I say 5y, and I'm going to set that over, and then what goes with 5y. So once the problems get a little bit more complicated, what you're trying to make sure you do is you need to make sure that you pick the side that goes with FD. Okay, so FD goes between a non-marked angle and a 90-degree angle. So which one would go with that would be this side over here, this 24. So I'm going to go 5y over 24 equals, okay, and this is where it gets a little bit more complicated because the next thing I say is give me something else from that same triangle. So from the 5y triangle, give me another number. Well, do you want to use 3y plus 0.5 or do you want to use 10z? But then you have a y and a z in the same problem, right? So you have to make sure if there's no other number, at least choose the part that has the same letter so that we can cross multiply that part, okay? So we're going to use this part right here, this 3y plus 0.5 over, and then what goes with that. So this one goes between the single arc mark and the 90. So over here, single arc mark to 90 is 15. Okay, and we're actually going to work this out because it's been a little bit since we've been working with proportions, but we haven't worked out too many that have like multiple parts, multiple pieces. So when we cross multiply, the first one we're going to do is we're going to take 5 times 15, so 5y times 15. That's going to be 75y. And this one gets people all the time. Okay, when we cross multiply here, I'm going to do 24 times 3y plus a half. So when you multiply that, do you just multiply the 24 times the 3? Or do you just multiply it times the 0.5? Or do you have to multiply it times both? And the answer is you actually have to do both. So when you're multiplying, it's almost like this has parentheses and you have to distribute. So it's almost like the distributive property. So 24 times 3 is 72 y's. Plus, and then half of 24 is 12. Okay, and then we'll go ahead and solve that by subtracting 72y. So if I minus 72y from both sides, I have 3y over here equals 12. So y equals 4. Okay, so then how am I going to find z? Well, to find z, you actually have to put this back in here. So 4 times 5 makes this 20. And now I can go ahead and find my z. because I have a number now. So I'm going to put that 10z on the top. So again, how I set up my proportions is I always make sure to put what I'm looking for on the top. So I've got 10z, make sure to get that in the problem. So 10z is what I'm looking for. 10z goes with 9z plus 7 on the other triangle. So then go back to the 10z triangle and give me a number. Okay? I can't give you 5y because then I won't be able to solve it, but I can give you 20. So now that I have that 20, and then 20 goes with 24. So now we're ready to cross multiply. Okay, so 10z times 24 is 240z. And then when I go this way, you have to multiply that 20 times both parts. That's the key here. So 20 times 9 is going to be 180z. Oh, I'm running out of space. And then 20 times 7 is 140. Should have made my 240 smaller. Okay, so then I'm going to subtract 180. So 240 minus 180 is 60z. Divide 140 divided by 60. And that gives you 2.3 repeating, which is 2 1/3. Okay. One more. So this one's a doozy. So the last one that you have to find is you have to find x. So the last piece of this is the x part. Now, if you notice, x is different than the y and the z. Why is it different? Because it's an angle measure, and that right there tells you that it's an angle measure. Okay, so we have 5x minus 8 degrees, and we have 4x degrees. Okay, and both of those are in a location that's not marked with arcs. So what do we know about the angles of similar triangles? They're equal to each other. So for the x part and the x part only, we're going to just set those two pieces equal. So 4x is equal to 5x minus 8. So the angles are equal, the sides are in proportion. Okay, so if you need that little note for later, we need to set the angles are equal to each other. So we're going to set those angles equal. I'm actually going to subtract the 5x from the 4x, so I'm going to have a minus 1x is equal to a negative 8, which just means x is 8. And there you go. Okay, so we kind of did every possible scenario you could kind of come up with in one problem. Okay. Okay, so same kind of idea here if we need to practice setting that up just one more time. So if you're trying to find x, let's just pick one of these x's to do. There's two x's in the problem, so I would pick maybe 8x plus 1. Okay, so the setup again. So hopefully this is helping if you're still not sure about that 6.1 homework, if you're still working on that. 8x plus 1 over, and then that's going to go with 22. Okay, here the angles aren't marked, so it's a little bit more difficult, but they did give you up top here that ABC is similar to DEF, so you can use that to try to find what pieces go together. So A and C would go with D and F. Okay. Now give me another number from the 8x plus 1 triangle. Okay, yeah. 27 over 18. I would go with that one too, because if you choose 15, then you have to work with 2 times the quantity x plus 1. It's way easier if we go 17 over 18. Okay, and then we would cross multiply and solve that. We're not actually going to solve that. Okay, we've solved enough already. Okay, okay, so the last little slide here on this just shows you your 3 options Okay, so angle, angle, side, 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 and side, angle, side. What this is also showing you is how you explain or how you justify or how you prove. Okay, so for example, if you want to say angle, angle, you need to say that these two angles are equal and those angles are equal, so therefore the triangles are similar. And then you would say by angle, angle. So this tells you exactly how to show it as well when it says show that the triangles are similar. Okay, I'm going to pop this back up on here. So we're back in the textbook. I know, we're so excited about that. But this is the last one in the textbook for the week until Friday, which is kind of unfortunate. So we're on 385. So for the next, so we get out at 15. So for the next like 15 minutes, I'm going to be walking around. And if you have questions on 6.1 or 6.2, let's get those taken care of before you start your 385. Okay, so those two. So the 362 and the 378, let's get questions on those taken care of first.